Hi, welcome to Module 11, Managing Data. If you're wondering why it's Module 11, well, it's a part of a 12-module training path that we have for ClickHouse developers. And clearly, we're getting close to the end. We've gone through a lot of information about how to get data into ClickHouse and analyze it. And in this particular chapter, this particular course, we have two very specific topics. I'm going to talk about compression. These files, ClickHouse stores its data in column files. You can actually pick compression for each column because they're in separate files. And so I'll show you how to define those codecs and configure that yourself. And then in the second part of this learning, we're going to talk about TTL, which is short for time to live, where you can define a time to live for the rows and columns of your tables. All right, let's get started. Talk about managing data in ClickHouse, and there's really two topics in this particular lesson. I'm going to start with compression, data compression, and then I'm going to talk about time to live. And not necessarily relatable topics or related. I suppose they fit into that category of working with your data. So when we talked about ClickHouse storing data in column files, those column files are compressed by default without you doing anything. All that data gets compressed using LZ4. And we've tried all the different compression algorithms. LZ4 is a nice sort of compromise between getting a nice compression ratio and also being efficient, because of course we want everything to be as fast as possible in ClickHouse. You can change that. You can set the compression algorithm to be other values, like there's an LZ4 high compression, that's the LZ4HC. And then there's the ZSTD compression. You get a lot better compression, but you pay for that in performance. Well, you might not care that much about the performance. The compression might be 30% more important to you than performance, because I see you get 30% better compression. And for what it's worth, now this isn't a ClickHouse Cloud tip. This is an on-prem deployment tip. If you want, you can specify the compression algorithms and these various settings. Like here, I'm changing it to ZSTD, and you can do that in the config files. So check the docs for the details of what these are. You can pick the part size and so on. Nice, if you just want to do it globally. What's more realistic, and you can certainly do this in the cloud or in any environment with ClickHouse, is you can specify at the column level what compression algorithm to use. Why? Because they're separate files. So if I want to save column 1 if I want to compress column 1 using the double delta codec, hey, that's perfectly fine. It's its own file. It's totally separate from column 2, where I decided to use LZ4HC. And column 3, I decided to not use any codec at all because for whatever reason, maybe the data is simple or something and you just want quicker access to it. So feel free to go through all these. I like my last one there where I put low cardinality string. That's just me being clever. Look, if you have a column, we've talked about this when we talked about modeling data. If you have a column of strings and there aren't that many unique values, we say around 10,000 or so or less, use low cardinality. That's the best compression you'll get because that's just storing a bunch of integers instead of string. In the lab, you're going to play around with the different codecs and what they mean, and you'll find them all in the docs, all the different options that you can put for the compression algorithms and the codec. It's very nice. So I just want you to be aware of that. I want you to know that that's a possibility. You can alter a table. If you have a table that's already filled with data and you want to change the compression algorithm, you can certainly do that. Now you'll have to wait for merges and everything to happen, but it might be worth trying that. Like I said, what you'll do in the lab is experiment. You'll take an existing table and try to make it more efficient. The end result's kind of interesting. You'll spend 5-10 minutes and realize that maybe LZ4 isn't so bad. Now, trust me, there are better codecs. For example, the delta codec's nice if you know that the difference between a previous value is small. You have a bunch of large numbers, but they're not too far apart. The delta codec just stores the difference. So you have this huge number, but the difference between the two numbers is 5. It'll store the 5 instead of the huge number. And so that's that particular codec. And there's other ones out there. Like I said, you'll play around with that in the lab. What you'll also do in the lab, just so you can get a sense of how it works, is you'll use that system.columns table and you'll actually see how good the compression was. And I do a little math. You'll see the math in the lab where you'll actually divide the compressed and uncompressed to get the percentage. So you can see how much the data got compressed. Very nice. It's all there in ClickHouse. The whole values and how much data is being stored and how much it would have been if it wasn't compressed. It's all there in the system.columns table. Should I worry about these compression options? Well, like I said, if you're new to ClickHouse, we don't recommend you waste any time on this. If you are at the point where your application is, you've jumped over a few decent sized hurdles. You've got your materialized views set up. You've got your secondary indexes and your projections defined, and you got a good primary key and you're pretty happy about things. Well, then you can stop and worry about, oh, did I pick a good codec or not? I mean, it is something that I suppose could make a difference if you have a massive amount of data. But in general, you just don't have to. You don't have to necessarily go out of your way to worry about it or focus on it. And I don't talk about encryption. Check the docs. You can also encrypt the data as well. Now, obviously, that comes with a performance cost, but a nice capability to be able to do that in ClickHouse. All right, so the second topic I want to talk about in this chapter is TTL. That's short for time to live. It's a merge tree table feature, any merge tree table. And it's a way to configure a lifetime for the whole table, or you can actually do it at the column level, and I'll show you both ways to do that. You specify a time interval. You can say, look, after a month, I want this row to be deleted. Well, what happens is after a month, the row, it gets marked as deleted. Now, it doesn't happen instantly, exactly 1 month from the moment the row is inserted, but it'll happen within a certain amount of time after it's marked for deletion. And obviously a merge must have to happen. We've already talked about in the chapter on updates and deletes, we've talked about how deletes actually work in ClickHouse, but just something to be aware of. And so that's the lifetime aspect of TTL. Now that second bullet on the slide where it says you can use TTL for moving data, well, that's a little bit different. It's not really a time to live, it's a time to move the data. And so after a day, for example, you can move the data off of a hot disk onto a warm disk. And after a week, you can move the data onto a cold disk. And you can easily set up a hot, warm, cold, frozen type architecture using TTL. And then the last example I show you is just kind of a clever thing you can do. You can actually roll up the older data by performing an aggregation on the rows that have expired. So let's take a look at the first example, which is I want my rows to be deleted after a certain amount of time. And look at the end of this table definition. You can see where it says TTL is now, so whenever the row is inserted, plus 1 month. And that's a nice common syntax in ClickHouse, this interval 1 month. You can use that expression in all sorts of date time functions. So what's going to happen? Well, when I insert a row, ClickHouse is going to keep track of when that row was inserted. Now, when does the row actually get inserted after the month elapses? Well, there's a setting in ClickHouse, and let's see if we can find it. Let's go over to the docs and search for TTL. Oh, here, there's a nice knowledge base article on it. And there's a property called merge with TTL timeout. That setting is already set. The default is 4 hours. What does that mean? That means that the most your row will live in this example would be 1 month plus 4 hours. Because if nothing happens, now this table has been sitting around for a month. These rows might be done merging. You're probably not actively inserting necessarily on those parts. The part might be too big to get merged. So the question is, well, when does it actually get deleted? Well, after a 4-hour interval, all your TTL rules are going to get applied. So at least once every 4 hours. That's what that setting means. If you need it to happen more frequently than that, then obviously you can change that value of merge with TTL timeout. All right, so that's how it actually works behind the scenes. So the question here at the top says, explain the TTL behavior of this table. Well, I still have the timestamp plus interval 1 month, so I picked one of the columns this time. So the rows will be deleted after 1 month from whatever the value of timestamp is. But after 1 week of whatever the value of timestamp is, the data is going to get moved to a separate volume. And here, my_volume is something that you'd have to configure. Go into the docs and you can see how to configure a volume. Let me see if I can find it here. Here we go. Storage tiers, and they talk about how to define a disk. And then if you scroll down, we show you how to define a volume. Oh, it's on the page here somewhere. Yeah, right here is an example. I see it. So a volume is a collection of disks. So yeah, this all has to be done in your config files in the cloud, ClickHouse Cloud. We don't worry about it. We don't worry about this in ClickHouse Cloud. But if you are setting up a hot, warm, cold architecture, you can take it to whatever degree you want. It is not that hard to configure. Now, these things I have in quotes, the hot, the warm, cold, and frozen, those have to be volumes defined in your config file. So I'm assuming they'd be different disks, which you would also have to define in your config file. And immediately it goes to volume hot because there's no time interval. So the TTL timestamp to volume hot means right away. After an hour, give or take 4 hours, it'll go to warm. After a day, give or take 4 hours, it'll go to cold. And then after a week, frozen. And after a month, it'll be deleted. There you go. That's the whole table. If I go back a slide, these TTLs are at the end of my table definition, and they're applied by the rows to every row. If you have a specific column that you want, you can actually delete a column. And then what happens is the column gets marked as deletion, and then it gets replaced, whatever the default value is of the data type. So if they're numbers, for example, after the TTL gets applied on that column, those numbers will be 0. If it's a string, it'll be a null string. If it's a date time, it'll be an empty or a 0 date and time. So whatever the default values are for the data types. And then eventually, assuming your TTL has some sort of logic to the timestamp and everything, you would think that at some point in time, all the columns in the column file would have expired. And if that's the case, then ClickHouse can just delete the whole column file off the file system. And that's how TTL on columns work. It's the same syntax. You just move it up to where the column definition is. So X is going to last for 1 week and Y is going to last for 1 week. I don't know what the difference is between timestamp and now, but whatever you want to use, whatever you want to define there. And all the same logic applies. The TTL rules get applied whenever the merges happen or every 4 hours, which kind of forces a merge, by the way. If you didn't define the TTL at table creation time, here's an example of adding it later. You can alter a table and modify a column and just apply a rule. Now that rule is not going to be applied immediately. You can materialize it. And in this particular example, by the way, both of these create mutations. This will be a mutation. This mutation doesn't take very long because all it's doing is changing the metadata, the schema of the table. This query it will return right away, but the mutation will execute right away. This mutation might take a while. Here, I'm telling ClickHouse to materialize all the TTL rules on my table, not just the last one that I defined, but all the rules. So it's a nice little command, by the way. If you're ever in a situation where you want to apply all the TTL rules to all your to your table, that's the command to do it. Again, it creates a mutation. Obviously, some merging will have to happen in the background. Force a merge, I don't know. I have the slide in here. I already talked about this in the previous scenarios. Don't merge a table unless you really know what you're doing, unless you're going to actually move the data. So you're not inserting any more rows into that part of the table, then it's okay to optimize that table because you're just going to get as few parts as you can and then move it off into some other storage maybe. And the last example of TTL is a rollup. If you want, instead of deleting, which is this particular command does not do any deleting of rows. What this command does at the bottom here is after the interval, there's a group by. If you add group by to the TTL command, well, then it's a rollup. And like I said, no rows will get deleted here. What happens is I'm going to aggregate the data. Looks like here from whatever day's worth of value it is, I'm going to sum up the values of X and store them in this column that I have called sum_X. And I'm going to figure out the maximum value of Y, and I'm going to store that in a column called max_Y. You have to make sure the aggregations make sense. I mean, doing something like average isn't going to make sense. Doing something like min, max, sum, yeah, those will make sense because those are easy to keep running values of. And clever. I mean, make sure whatever logic you come up with, make sure you verify that it's working properly. And so anyway, that's how you do a roll-up. In the lab, you're going to, like I had said before, play around with the compression. It's a nice lab. You're going to try and figure out what's a good compression algorithm for the table that you already have, the UK prices data. And then the other thing you're going to do is define some TTL rules, and then you're going to force them to trigger ahead of time so you can see that it's actually happening. So it'll be nice practice to check out both working with compression and codecs and working with TTL. All right, off you go. Good luck. Be sure to reach out for us for help, clickhouse.com/Slack or learn at clickhouse.com. Thanks.